Welcome to another video where today we will be applying the binomial theory that we saw last video into actual exercises. So, let's start right in. Last class, we basically saw that the formula for the binomial theorem was a plus b to the power of n is equal to the sum of n and k, which is equal to 0, n k, a n minus k, b k. So, how do we apply this to actual problems? Let's start with a simple exercise. 2x plus 3 to the power of, let's say, 4. So, let's say we would like to find the coefficient for x to the power of 3. Well, here, what we can do is either apply the formula until we get this coefficient, or solve it through a method which is called commonly by identification. Let's try this method as we will need it to solve more complex examples. Maybe not the simple one, but yes, more complex examples. So this example is pretty much like this. We use the formula first to obtain 4 and our k. Then our a is 2x, so let's say 2x 4 minus k, like we see here, and minus k, and this is multiplied by 3 to the power of k. So we can simplify this further into 4k, and what we need to do is keep our x separated from our coefficients. So 4k and 4 minus k, we can separate our 2 and our x, since this would be just 2 to the power of 4 minus k times x to the power of 4 minus k, and everything is being multiplied. So 3 to the power of k and x to the power of 4 minus k as well. And this we use, let me erase this, we use an arrow, like so. Let's write coefficient of x to the power of 3, did I say? Yes, of 3. So, all of this is our coefficient, and all of this is our x to the power of 3. That's why it's called by identification. So, what we have to do here is first equal x to the power of 4 minus k to x to the power of 3. Here, what we have to do now is find k. We can just do this by doing the natural logarithm, just logarithm of x, logarithm base x of x to the power of 4 minus k, which is equal to logarithm of x to the power of 3. We cancel these two out, as this is logarithm x of x, and this 2 x of x, and we obtain 4 minus k is equal to 3. If we isolate x, we have that k is equal to 4 minus 3, which is equal to 1. So, let's just input this now in our in these values in order to find our coefficient. 4k times 4 minus k times 3k. So, since we have our k, we can say that 1, 2, 4 minus 1, and 3, 1 is equal to 4 and 1 is 4, 2 to the power times, 2 to the power of 3, or 3 there, times 2 to the power of 3, times 3 to the power of 1. This is equal to 4 times 2 to the power of 3 to the power of 3 is 2 times 2, 4 times 2, 8. 4 times 8 is 32, and 32 times 3 is 96. So we have that our x to the power of 3 coefficient is 96x cubed. And this is our result. Now, this may seem like it is pretty complex, but once you get the hang of it, you will do this very fast and you can skip a few steps. Also, you may think that applying the formula is much easier by just expanding this, but as we said before, this is easy if you have an n that is a low number, like we had here, which was 2x plus 3 to the power 4. But imagine if you had to find a coefficient of 102. Then expanding it until you got to the coefficient of 102 would be extremely, extremely long. Therefore, using this method of bi-amplification is way shorter and it is less time consuming. Thank you for watching. That will be all for today, but we will continue in the next videos practicing exercises of binomial theorem as well.